Nicholas Bloom, Associate Professor of Economics at Stanford University in the Business School, explains a rare field experiment conducted between 2008 and 2010 that provided evidence that good management practices add value to the bottom line of manufacturing firms. The experiment by Stanford and World Bank researchers was conducted in a textile manufacturing center in India. Bloom's presentation was at a September 2010 academic conference honoring his co-author, John Roberts, the John H. Scully Professor of Economics, Strategic Management, and International Business at the Stanford Graduate School of Business.
So the idea is to try and run a field experiment on management practices and to try and see if we can get some causation from management to performance. And going to Scott's challenge earlier, it is an open question as what matters. And Jonathan was saying earlier, is it complementarities, or can we show there are any practices that even in small changes have an impact? So the way we tried to go around addressing this question is we took a bunch of large firms, whereby large firms I mean 300-person firms in Mumbai that work in textile. So why Mumbai? Well, Mumbai is the commercial capital of India. India is a very nice place to do field research in. It's a developing country, and it's pretty cost effective. It's nice to go out and work there. And we picked one industry, which is broad woven textiles, cloth, so basically cloth in shirting and suiting. And we randomly selected these large firms into treatment and control plants. The treatment plants got 6 months of consulting, free consulting from another consultancy firm, not McKinsey, Accenture in this instance. And the control guys got a month. So why did they get a month at all? They got a month because one of the classic problems in field experiments is you have to get data off the control group. So it's always a problem you face. It's very easy to deal with the treatment guys. You go in there, you give them something that they want. You collect data before and after. The control guys, you've got to get before and after data. So in that case, we have very heavy treatment for 6 months for the treatment guys, basically light treatment for the control guys, and an ability to collect data. We're going to collect weekly data on all the plants we have done for 2 years on a whole range of outputs. And I'll show you this in a lot more detail, but basically the broad things we found, one of them given the discussion earlier, it's not obvious actually how predictable it is. Depends kind of what angle you come from. But you see very large increases in profits and productivity. And because of the randomized nature of the intervention, you can argue this is causal. A lot of it's just come through better quality control. And I'll show you a set of kind of much more detailed evidence. But basically, these firms are in what I call the kind of Fordist model of production. They make massive amounts of cloth. They make it as fast as they can. And then about 20% of their manpower is involved in fixing and repairing at the end. And part of the intervention is trying to move them slightly more towards a more modern manufacturing process of if you find a defect, fix it on the spot so it doesn't permeate. And a second issue is around decentralization of power within firms. John's also, as we discussed earlier, has also been involved quite heavily in theories on organization of the firm. And what's one of the things that was less obvious to us and just turned out as we ran the experiment is better management practices have led to pretty heavy decentralization within firms. And again, talking to Bob on this, I guess my interpretation of it and what we see in the ground is the better management practices improved informational flow within the firm. So the owners have felt more relaxed about letting plant managers take decisions, in part because the owners know what's going on, in part because they can spot theft. And then finally, there's been a big increase in computerization. So basically, as you've needed to collect and process data more, you can use more computers. So as backdrop, what do these places look like? Here's a picture of one of the factories. I put these up to give you an idea. These are large factories. Typically, this is one building. You can see it's in a gated compound with several floors. There are typically 2 buildings per factory. Most firms, the medium firm has 2 factories and a head office in downtown Mumbai. So I put this up to kind of highlight these are complicated organizations. My sense in terms of manpower and complexity, there may be a similar size to something like the GSB. I don't quite know how many employees the GSB has, but they're big. They operate 24 hours a day. There's no way you can run them in an ad hoc manner. Here's a second plant. Again, you can see a large complicated facility. Here's the first stage of the production process. Coming back to Paul's talking about CAD/CAM in terms of CAD/CAM being an old technology. You can see some of this stuff looks like it's left over from imperial India. I think there's some pretty old equipment lying around. This is the first stage of making fabric. So when you make fabric, what happens first is you get all these spools of yarn. So the input to this is yarn thread. Upstream, there's a separate industry called spinning, which takes kind of bundles of cotton and spins it into yarn. And this machine rotates at incredibly high speed. and basically winds all this yarn onto something called a warp beam. So that's stage one. This thing would spit out several warp beams a day. These warp beams are then fed onto basically into the second stage, which is called weaving. And here are these warp beams. These things rotate round, and this shuttle goes back and forwards very fast and puts the cross thread. So that's the weft. So all fabric has a warp and a weft thread, and once you put both of those through, coming out the far end of this machine is the fabric. So reams of fabric come out very fast. Because of the way these factories are set up, because their quality is basically very poor, the third stage is a massive mending and repair area. So they'll have huge rooms full of people who are spreading cloth out over these backlit wooden structures. You know, even the fact that they're manual. When I was in China earlier, and about a couple of months ago, and some of the Chinese factories have automatic things that pull this cloth down. These guys are pulling this cloth down manually, spreading it out, looking, finding defects, mending it, pulling a lot of cloth down further. It's very time intensive, and it takes up about a fifth of the manpower. And also, I mean, the other downside is they can't fix anything. They're throwing away, on average, about 7.5% of the output because the quality is so poor. So in fact, I should ask Paul to raise an anecdote. I remember he told me a story about well, why don't you tell the story about when you were the stamping in I think it was the hubcaps, that this isn't a problem unique to India.
So when I was an undergraduate, I worked in the General Motors factory where we were making bumpers. And I was on the repair section where if a bumper came through and had a flaw, I was supposed to take it off the main line and put it onto the repair line where it would go by a repair machine, get polished, and get put back onto the main line. This was after it went through copper plating and then chrome plating, and then nickel plating, and it was after the nickel plating and before the chrome plating that they would do this repair. And one day there was, I went there and there was a flaw in one of the presses, and every bumper that came down the line had a flaw in the same place. And I was moving the entire production line from the main line onto the repair line, where these racks, and they'd go by and until they were repaired, and the repair line got completely filled. There was nowhere left to put the flawed bumper, so I pushed the stop button on the line, and the plant manager visited me and told me, "You never push the stop button on the production line. Never push the stop button." Anyway, I got read out for doing this, and I said, "Well, what am I supposed to do?" And, and put them on the floor, put them anywhere, but don't push the stop button. That's the story.
That's U.S. Automotive, I guess, before Lee.
This was Oldsmobile.
I mean, that anecdote struck me as so representative of what's going on in these factories. So I'll come back to it in a minute, but the same defect is just going through and through and through, and they're just producing the same defect just, continuously. And this is why 20% of the guys, and they're fixing the same thing. You can imagine how frustrating that is. The factories are also just generally disorganized and dirty. Here's various shots from factories. I mean, we have 20 factories we visited. You could never get a shot like this from a US factory. I mean, to the extent you could ever even find this, there's no way they'd let you take a photo of it and put it up on a presentation. I mean, out there, it's no big deal. I'm taking photos of this kind of thing. And it's very hard to get high levels of efficiency when your factory is in general chaos. The plant floors are often disorganized. The aisles are blocked. I mean, this is the complete reverse of lean manufacturing. You can see you need to get equipment up and down the aisles. You need to get warp beams in and out. You need to get, when you doff the fabric at the end, you need to get the fabric reams out again. Here there are some table and chairs. They couldn't really explain what it was here for. Apparently been here to mend something historically. They kind of left it around. Here's an old piece of equipment. None of it is like endemically terrible. You add this all up, you can see I can get pretty low levels of efficiency. Another thing you notice is the repair system was kind of very old school in the sense of you just repair stuff when it breaks down. So again, the whole modern manufacturing theory is you repair stuff in advance, you have routine maintenance. Why? In part because it's more efficient probably to repair stuff in advance rather than wait till it breaks down, but also primarily it reduces variability. So a big problem is you're trying to deliver an order and your machine breaks down at the last minute. You generate huge variability in output. Inventory rooms are pretty chaotic. So here's just bags of yarn. Yarn's a big deal for them. It's expensive. Labor's cheap in India, but capital's expensive. Materials are relatively expensive. Not much ordering. Here's another yarn storeroom. We didn't actually try and do anything particularly high level and complex. We went for basically extremely basic, low-hanging fruit, the kind of stuff that, at least our belief is, there is some complementarities between them. I come back to them, but even individually, they're good. So things like preventive maintenance is carried out for the machines, is carried out following the manufacturer's recommendations. They don't make up their own maintenance schedule. They do what it says in the manual. The shop floor is marked where the machine should be. Some stuff about quality defects. When you have a defect, you record it, you analyze it, etc. So it's stuff that in European, US factories would be pretty standard. In these factories is, frankly, as I'll show in a minute, pretty not standard. Some stuff on inventory control, etc. So here's a bit of data. So what we did is we recorded the adoption of these practices before, during, and after the intervention. So here is months before the initial diagnostic phase. So what happens is all the plants have 1 month of an initial diagnostic phase, both treatment and control. And the diagnostic phase goes in there and basically collects data, including builds a back series of data going back a year, and then gives them a set of recommendations on what they should do. So tell them you need to put in inventory control, quality control, etc. The treatment guys then get another 4 months implementation that helps them carry it out. The control guys who basically leave and come back 1 day a month to collect further data. So what you can see is in advance of the consultants turning up, they're adopting about 25% of those practices. So the stuff I showed you, they typically don't have, quality control. They typically don't have routine maintenance, etc. The consultants go in at month 0, and several things. Some of them are kind of surprising. So less surprising, the treatment guys improve. So they adopt a lot of these practices. The consultants are sent there on the ground. There are Accenture guys. There's 1 person for every 2 plants. It's pretty intensive. They're there for several months. They manage to get them to adopt quite a lot of them, but they don't manage to get them to adopt anywhere near 100%. So, one big challenge is why on earth they have experts that are very expensive that are there, that I'll show in a minute, are showing kind of proven impact. They don't listen to them. The control plants improve, but by much less, and this is how we're going to get identification. There's a third group of plants that are interesting, which are these things called the excluded plants. So these firms own multiple plants each. And we don't actually provide treatment control to every plant. So if, Catherine and Jonathan each own a plant in one of these firms, you may have Jonathan as a treatment and Catherine is completely exempt. She's neither treatment nor control. So she would be an excluded plant. And we go into those as well and collect management data. And what you see is this is increasing to some extent, and this is entirely copying. So we're not sending consultants in on the ground. They're just basically replicating it over. Again, there's kind of this leaves as many questions answered as it solves, in the sense that, why is it they don't copy a lot of this over? So, they're copying some of it. There's very slow adoption. But certainly this changes over time. One of the things that's kind of interesting is we know from the anecdotal, I guess, PE and kind of consulting literature, it takes several years. I mean, Jonathan was coming back to earlier. It takes just a long time to change practices. We're in there for a year, and it's just very tough to put in place big changes. What do we do? So what are the areas we see improvement? So one of the things I mentioned is quality. The biggest single improvements in terms of productivity really come from better quality. So beforehand, massive amounts of manpower, 20% of the manpower spent on repairing defects, about 7.5% of outputs thrown away. How do they fix this? Well, is a set of kind of very simple systems. Historically, they have these things called quality logbooks. So every time there's a defect, they write it down in the checking stage, who the weaver is, the piece number, the machine number, etc. They write down some information, and then there's a quality grade. So A is the top grade. It means perfect. Below that, by the time you get to D, it's basically rejected. So AB means pretty good piece of fabric, but there's some small defect in it. They record this because buyers are often asked for refunds and say, hey, my piece of fabric had a hole in it, I want my money back. And they have to go look at their logbooks and work out whether they give them their money back or whether the buyer's basically trying their luck. But they never really systematically analyze it. So one of the things consultants get them to do instead is change the recording format that something looks like this. It's actually faster to record it in. And it has the weaver piece number, etc. But the key difference is they have columns for each of the major defects. So here there's a 2 in the broken pick, which means there's some broken pick defect in the fabric. And this is a big change for them because they computerize it. So this they can now feed into the computers. Every day they now meet up. They analyze the quality defects numbers. And this is extremely effective for improving quality because you can look at defects, you can spot them quickly and fix them. So a good example of this would be stains. So a lot of the fabric will have a staining problem on it. So particularly, if I look at Paul's shirt, it's a white fabric. If that has oil stains in it, I don't think it does, but if it had oil stains in it, it would be a problem to try and sell it. Oil stains sound easy to fix, but they're not actually that easy to fix because they come from multiple sources. So one thing can be that the guy handling the weaver hasn't used gloves. Another thing can be the oil ducts have broken and stuff's leaking out, or someone can have overfilled, the oil valves. once you have the quality defects data, it's much easier to fix it. You can see that it's one weaver, one shift, one piece of machinery. They fix it. As soon as they fix it, they deal with it. So you don't get the kind of the problem Paul was talking about of thousands of defects running through. And here's, in a sense, the output data for quality. There's something called the quality defects index, which is a weighted average of quality defects. A very high number means low quality. It means bad quality. So here's bad quality up here. Here's good quality. We normalize in red the control and in black the treatment plants before the experiment. They're basically, there's a bit of movement around here, and you can see the standard errors are reasonably wide because we don't have a big sample. But after the experiment, the treatment plant's quality improves while the consultants are here, and there's a kind of mild, although not significant, ongoing downward drift. So what's happened is quality defects have fallen by about 50%. And this alone is an enormous improvement for the firm because they can save 10% of manpower, increase output effectively of about 3%. So you can do similar, so you can show in a regression table it's statistically significant, etc. So then you can do similar things for inventory. Beforehand, now we reorganize the inventory, put it on shelves, we bag it, put labels, enter it into the computer. Various amazing things happen when they do this. For example, one of the plants discovered they used to make shirting and suiting fabric. When they organized their storeroom and recorded all of it, they'd stopped making suiting about 2 years ago, but they discovered large bags of suiting yarn in the back of their storeroom. And, you realize they've held this stuff for 2 years. Of course, they can now sell it off, but no wonder they're carrying excessive inventory. The other thing they do is, to the extent they have excessive inventory, they make shade cards. So these are cards that record what the fabric is, write a bit of information about the strength and the stitch. They send it to the design teams down in Mumbai, and they design it into new products to try and get rid of the excess inventory. And again, inventory falls over time. And then finally, output. So they did a set of changes in output, marked out the factory floor, did these things called snag tags, where they go around, they put these little labels on the machine so that when the when the maintenance men come around, they can pick off the tags, spot the defects, organize the spare parts, the tools, went from kind of the very old scrappy handwritten notes to computerized records. Here's my favorite photo. You can tell how well they're looking after their records based on the large footprint on the record. You can see how carefully they're monitoring stuff beforehand. They put up these boards. I mean, it's an interesting question on piece rates. They don't provide extremely high piece rates, but they now give them about 10% piece rate with the board. So again, an issue, I guess, on complementarity. There's no point providing piece rates if you don't provide feedback to the workers because they can't tell how they're doing. As soon as you put in piece rates and you put them up on the board, it's relatively easy for them to tell who's doing well, who's not doing well, and cross-compare. And again, performance improves. Another thing that we note, by the way, that's kind of interesting that you get from the regression tables is in column 1 is running OLS. So this is exactly the same as Kathy, for example, Ishkanashi's Kiran Pranushi. So what we do is we have a panel of performance data and a panel of management data, and we run regressions where we put in basically plant fixed effects and time dummies. So we're looking at the change in performance versus the trend, versus the change in management versus the trend. And you see here, in this case it's not significant, but in many of the indicators we typically get a significant effect even in the OLS. In the second column we go to instrumental variables, so we instrument the change in management with the amount of treatment. So basically you're getting an entirely causal effect. And you see in almost all of these coefficients go up. In this case, the impact and output's tripled. And the reason this happens, and I think comes back a bit to the reason these guys are badly managed in the first place, is they don't tend to change until stuff goes wrong. So what's happening is you have these factories, performance is going along, on average it's even improving. They're not that receptive to the management changes. As soon as things start to turn down, performance starts to slump, they're much more receptive to changing management practices. So, the effects that you see in OLS seem to be a downward bias from what we'll get in terms of running experiments. So when you run cross-sectional surveys, the extent we get something, at least on our evidence, suggests that the true impact may be even larger. So we also look a bit on decentralization and IT. So I mentioned you see another change you see going on in these factories is decentralization of information from the of control from the owners of the firms down to the plant managers. So a typical situation is, imagine I'm the owner, you have Peter and Bob as the two plant managers. So I'm the owner, I live in Mumbai. the town is Tarapur, so about a 3-hour drive outside Mumbai. I typically go out to Tarapur every day, spend half the day at Peter's factory, half the day at Bob's factory. Of course, I, as the owner, don't want to do this particularly. I'm spending a huge amount of time commuting there and back and forward. I'd much rather let these guys run the thing without me. The problem is I can't trust them in my absence. So one of the problems you see, for example, is a lot of theft. So if I don't turn up on the factory, I worry that Bob, for example, is stealing parts from the factory, reselling them. You know, I don't know what's going on. It's hard for me to stop this, so I have to come in every day. If instead you start to have detailed performance metrics, I can track things on a daily basis. It's much easier for me to spot what's going on. I don't need to turn up as much. I also rely that Bob has a better ability to run his own factory. So when you give them better management tracking systems, better information tracking systems, we see increased decentralization in the sense the owners don't turn up to the factory as much. The plant managers have much more autonomy in hiring and investment. And we measure it here in a range of different indicators and take the average. But this decentralization index is kind of an average of hiring decentralization, investment decentralization, choice over plant and products of the factory manager. And this is increasing very dramatically in the treatment firms versus the control firms. The other thing we look at finally is computers. So these factories are pretty low tech in terms of computerization. So here's a picture of actually a relatively high-tech factory. Most of the factories will have one office out on the factory floor with some guys using computers. Here are kind of the old green screen computers. The average factory will have something like 2.5 computers for 3,000 people. Here's a much more low-tech setup where one woman with a computer in the corner and her dot matrix printer. Quite a few of the plants don't have any computers at all. Again, we see very big effects on computerization. And the reason for this is, in some sense, pretty intuitive. If you put in process these modern practices involving data collection, data processing, data analysis, you need much more computerization to do it. So coming back to the discussion of complementarities throughout the day, you can see that clearly there's a complementarity between, kind of Bengt was talking about earlier as well, between capital and practices.
But also, I mean, it's not just that they needed the computers to put in the systems, but they use the computer much more intensively than they used to. So there are a lot more people who are looking at computer-generated reports and are running things on the computer and whatnot.
Yeah, it's a very good point. I guess we highlight that in part because of this big debate over skill bar's technical change, the kind of finding that you see in the US, in Europe, across Europe, a big increase in income inequality. And part of the reason people think this is going on because of an increase in the returns to skills. But what is the technology driving this returns to skills? Well, coming back to what Kathy was talking about earlier, one of the technology we think may just be improvements in management practices, because modern management practices are much more IT intensive. The use of IT requires much higher level skills than traditionally, for example, in these factories. So as you if you adopt modern management practices, you just see there's more hours spent on the computer, which increases the demand for people that can use computers. So for these factories, this is being kind of IT intensive, but also skill intensive. Finally, why aren't they introduced before? There's a lot of issues about the market. So I'm going to skip this when I get onto the kind of final set of stuff. But basically, they have very high tariffs. Chinese inputs, which are the obvious competitors, heavily tariffed. It's very capital intensive, so hard for new entrants to enter. And it's very hard for the current successful firms to expand. They have this big problem about reallocation. So coming back to the Peter and Bob story, if I'm the owner and these are my two factories, and I have to spend all my day managing one of the two of them, it's very hard for me to set up a third factory. And in fact, the best managed firms out there, when you ask them, why don't you expand? They're very profitable. Why don't they expand and set up new factories? The primary reason is I don't have enough time in my day. I'm already running two factories. The only reason they manage to do that is basically have people they can trust. Who are they? Their brothers, brothers-in-law, sons, etc. So the thing you find out there that seems to explain firm size is number of male family members, the people they trust to run the firm. So the biggest firms are the guys with 4 brothers. The smallest firms typically tended to be the person, the brilliant guy but had no brothers and no sons, so he had no one to. India has the kind of the same formal legal system as the UK, but just has a very slow court process. So when you ask them about can they borrow money, yes, so they have collateral to start off with, but as an outsider, no. So none of it's impossible, and you'll come up with stories of people who've done this. So most of the owners started off by trading, and then they maybe bought 10 looms, and then they did well and scaled up. The kind of US example of fantastic manager raises a lot of money, mortgages his house, and goes in and starts a firm is it's not zero, but it's very low. So it's like a market in treacle. Everything's moving very slowly. So it's not like reallocation doesn't happen at all and entry and exit doesn't happen at all, but it's a slow process. And so you get these firms that persist, that are badly run, that are making money and aren't driven out of business. And the other question is, why don't they improve themselves? Well, the evidence we found on the ground is primarily informational. So when you go in there and ask them about it, they've mostly heard of so there are several hypotheses about it. One is they've never heard of these practices before. That's mostly not true. Most of this stuff they've heard of before, they're aware of it. The big problem seems to be they don't believe it matters. So for example, on the quality issue, you'll go talk to them and they'll say, you can improve your quality by introducing quality control systems. And they go, but my quality's good. It's better than Vinod's down the road. I don't have a quality process, quality control process problem. And in a sense, it's true compared to their local competitors. And it's related to the fact they don't face global competition. But in the bigger scheme of things, their quality processes and many of the other processes aren't fantastic. And they look like European and, I guess, US firms of 20, 30 years ago. There's a frontier. It's improving over time. Indian firms are 30 years behind the frontier. This is kind of moving them 15 years towards the frontier, and the frontier will keep evolving.
The fact that the Indians are bad, so many of these firms are badly managed, and it's an informational problem. Think about the U.S. auto industry. It took it at least 20 years to figure out what the Japanese were doing differently and to come anywhere close to implementing what was well documented. It was no secret. But they just initially wouldn't believe it, and then couldn't believe it, and then couldn't do it.